Morning, grade 7s. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all very well this morning and looking forward to today's lesson. Just a reminder of the email address on your screen, grade7@worksheetcloud.com. As always, please feel free to use it to send me any questions or queries or feedback or suggestions. There might be a topic that you'd like me to cover in more detail or go over, and I'd be happy to do so. Also a reminder of the online activity and memo that accompanies this lesson. You can look at it as homework or you can look at it as consolidating the principles learnt. Either way, I would encourage you to do that online activity just to make sure you understand and you know the content and the concepts that we're trying to teach you going forward. So please guys, a reminder to have a look at that. So today we're going to have a look at algebra and we're going to have a look at multiplying terms. So what happens when we multiply letters and numbers in algebra. So please have a close listen. And then we have our warm-ups, mental arithmetic questions based on previous principles, and then our brain bender and finisher to close off the lesson with. So let's have a look at our warm-up for today. It's a fraction theme. And I'm sure you guys know by now that you need to give me the value of every symbol as well as the question mark at the end. Please write it down so you can see your thoughts. It will be difficult for you to do everything mentally. Some people say that the brain can only hold 3 pieces of information at a time. So yeah, write it down. Take your time, check your work, and don't worry if you have to restart. That's all part of the process of learning how to do mathematics. So off you go, and let's see how you get on. Look at this fraction-based puzzle. I'm going to start on the third line, and I know that 12 multiplied by a half is equal to 6. Okay, so remember when we multiply a whole number by a fraction, you can put that whole number over 1 so that you've got 2 fractions. Okay, and then remember when we multiply fractions, you can either say 12 times 1 is 12, and 1 times 2 is 2, and 12 divided by 2 is equal to 6. Okay, let me just rub that out there. So that should be 6. Okay, alternatively, remember, we can say 2 goes into 2 once and into 12 6 times, and then we've got 6 times 1 as the numerator and 1 times 1 as the denominator, and that's equal to 6. Okay, so your palette of paint is equal to 12. Right, then I went to the top line, and I know that 48 multiplied by a quarter is equal to 12. So again, if I put 48 as a fraction, and I put 48 over 1, okay, then you can see if I multiply the numerators together, I get 48 times 1 is 48, and the denominators, 1 times 4 is 4. So essentially 48 over 4, which is 48 divided by 4, which equals 12. Okay, so your microscope over your microscope's worth 1 and your light bulb is worth 4. Okay, so then we get to the line underneath, so the second line, and we've got 1 quarter plus 1 quarter equals something over 24. So straight away you might look at this and go like, hang on, when you add fractions the denominator doesn't change, and you're 100% correct. Okay, however, a quarter plus a quarter is equal to a half. Okay, and we know that the palette of paint is equal to 12. So what does 12 over 24 equal to? It is also equal to a half. So it's an equivalent fraction of a half. So I know that that equation must be correct. So a quarter plus a quarter is equal to 12 over 24 because 12 over 24 is equal to a half. Okay, now we go to the bottom line and we know the light bulb is equal to 4. The paint is equal to 12 and the microscope is equal to 1. So what order do we do this operation or this equation in? And you know multiply comes first. So 4 times 12 is 48 plus the 1 is 49. And that's our final answer. So guys, go back and rewind and listen to my explanation of this puzzle again. It's really useful for you to be able to manipulate numbers and to realize, for example, on the second line that a quarter plus a quarter is indeed actually equal to 12 over 24 because that's also a half. yeah, I encourage you to make sure you fully understand it before moving on. Let's go have a look at our mental arithmetic for today. There are your 9 mental arithmetic questions for today, all covering previously past taught principle, addition, subtraction, long multiplication, some division, fractions, and then percentage to finish off with. Take your time, write everything down logically and neatly. Please remember to check. Get used to practicing your checking strategies. I've identified in previous lessons where I've made mistakes, checked, and then been able to correct those mistakes. And that's what it's all about, just to help you prevent making careless errors or help you identify where you've made careless errors. Okay, off you go. No rush. Take your time. Let's see how you guys get on. Okay, question number 1, 0,871 plus 0,17. Okay, so no units, 8/10, 7/100, 1,000th, plus no units, 1/10, 7/100. And just for visually to make the two numbers have the same amount of digits, I'm more than happy for you to put a 0 in after that 7 on the second line. So now I know that 1 plus 0 is 1, 7 plus 7 is 14, carry the 1, 8 and 1 is 9, plus that 1 is 10, decimals line up, and I should have 1,041. How do we check an addition sum? Any addition sum, we can take the answer and subtract any one of the numbers in the question. Okay, and I'm going to choose 0,871. So now we are hoping to get an answer of 0,170. Okay, so let's check if we do. 1 minus 1 is 0. Okay, those two are good. I can't do 4 minus 7, so I need to borrow. So it becomes 14 minus 7, which is 7. So those 7s are both all good. 9 minus 8 is 1. The decimals line up. And 0 minus 0 is indeed 0. And I can see now 0,71 and 0,170 and 0,170 are identical. So my original calculation must be correct. Right, let's move on. Okay, next we have a subtraction calculation, and that is 9,81 minus 2,539. And again, I would encourage you to fill in that 0 there, just so that both numbers have the same amount of digits, and it's just visually easier to see and to look at and to understand. So I'll subtract normally. I need to borrow. So 10 minus 9 is 1. I need to borrow again, so it becomes 10 minus 3 is 7. 7 minus 5 is 2. Decimal lines up. 9 minus 2 is 7. So remember, the checking strategy for a subtraction sum is to do addition. So I'll add 7,271 to 2,539, and will I get 9,810? Well, let's check it out. 9 plus 1, 10, yes. 7 and 3, 10, yes. 2 and 5, 7, absolutely. And 7 and 2 is 9. So happy days, it's correct. I can move on. Please, guys, use that checking strategy. You'll be amazed at how it can help you. Right, so next we have a long multiplication question. 1,672 multiplied by 43. Multiple methods that you can use. I think for today, the method I'm going to use is a column method. But as always, you guys can choose whatever method you like to use. I'm going to end up doing 2 methods here, just to prove whether my original calculation is correct or not. So let's get this done. 1820, so that's going to be 5. So 1,672 multiplied by 3 is 5,016. Then remember, I need the placeholder of 0, because I'm now multiplying by 4, but it's not 4, it's 40. Okay, and 40 is a multiple of 10. So whenever you multiply by a multiple of 10, it ends in 0, which is why we have this guy over here. So now 4 times 2 is 8, which is actually 40 times 2 is 80. 4 times 7, which is actually 40 times 70. We're going to put, 4 times 7 is 28. So we need to put the 8 down again and carry the 2. Okay. 4 times 6, 24, plus the 2 is 26. And again, we must carry 2. And 4 times 1 is 4, plus the 2 is 6 again. And now it's just a case of adding up. And we should get an answer of 71,896. But I'm going to go and try another method just to see if we do indeed get 71,896. And what I'm going to do is I'm going to split 1,672 into 1,000, 600, 70, and 2. And I'm going to split 43 up into 40 and 3. I hope that I'm going to have enough space. We'll have to make space. Okay, so 1,000 times 40. We know 1,000 times 4 is 4,000. So 1,000 times 40 must be 40,000. Squeeze that in there. 1,000 times 3 is 3,000. My apologies about the running out of space, but I'm sure you'll get the idea. 600 times 40, 600 times 4 is 2,400. So 600 times 40 is going to be 24,000. 600 times 3 is 1,800. 70 times 40, 2,800. 70 times 3 is 210. 2 times 40 is 80. And 2 times 3 is 6. Okay, so now we add up each column. So 40,000 and 24,000 is 64,000. Plus 2,800, 66,800. So that's going to be 66,880. And on the right-hand side column, 3,000, 4,800, 5,010, so 5,016. Okay, now if I add, and I'm going to have to just create some space here, which I'm sure you guys don't mind me doing, 66,880, and I need to add 5,016. So I don't know if you guys saw that, but I wrote 5,016 starting with the units just so that I could make sure that I had the correct numbers in the correct column. It's just a handy little trick that I use sometimes. So are the 6s the same? Yes, they are. Are the 9s the same? Yes, they are. Are the 8s the same? Yes, they are. The 1s the same? Yes, they are. And the 7s the same. So I'm happy that both methods have resulted in the correct answer. Guys, as always, remember that you can go back, press rewind, press pause, listen to what I have to say. So it's quite handy that you guys are able to rewind and listen and rewind again and have these recordings at your disposal. And I'd encourage you to use them as much as possible. Question 4 is a short division. Okay, so we'll say 5,613 divided by 3. Okay, so a short division, I'm only dividing by a single digit. And 3 goes into 26 8 times with 2 left over. And you're going to have 1,871. But remember to check. We need to multiply the answer by the divisor. And we should end up with 5,613. So the 3's are the same. The 2's are the same. The 6's are the same. And the 5's are the same. So I'm happy. I can move on to question 5, which is the fraction question. So we're subtracting fractions here. And I'm pretty sure you guys remember and you know by now, you're probably sick and tired of me saying it, that when we add and subtract fractions, we need to make the denominators the same. So what's the lowest common multiple of 6 and 2? That's right, it's 6. Okay, and 6 goes into 6 once, so 1 times 5 is 5. 2 goes into 6 3 times, so 3 times 1 is 3. And then if I work that out, I get 2 over 6, which is equal to 1/3. Okay, so that's subtraction of fractions. So the key there is to make sure the denominators are the same before you go and work them out. And remember, it's the same for addition and subtraction of fractions where the denominators need to be the same. 5,42 divided by 100 for question 6. We know that when we divide by 10, 100, or 1,000, the number gets so many places smaller depending on how many zeros there are in the number. So depending on if it's 10, it gets one place smaller. If it's 100, it gets two places smaller. If it's 1,000, three places, and so on. So for this number to get one place smaller will be 0,542. So we're looking at 0,0542 because the number gets two places smaller. Question 7, we have the division of a fraction by a whole number. And I always encourage my students to try and get two fractions. So remember, 3 can be written as 3 over 1. Okay, so now I've got two fractions. I know that it becomes multiplied by 1 over 3. So the division sign changes to multiply, and the fraction after the division sign becomes the reciprocal. And now I can just multiply normally. 4 times 1 is 4. 5 times 3 is 15. Okay, there was no scope or no potential for me to cancel out diagonally before multiplying. So I'll just multiply the numerators together and the denominators together, and I get 4 over 15. Question 8 is a quarter multiplied by 6. So you can either do it normally. So a quarter multiplied by 6 over 1. Okay, and here we have, let's just wait for it to come up. There we go. Here we have the potential to cancel out diagonally because 4 and 6 are both even. So we can divide both by 2. And now we're going to be left with 3 over 2 because 1 times 3 at the top is 3. 2 times 1 at the bottom is 2. And you can either leave that as an improper fraction or you can write it as a mixed number, 1.5. Okay. You can also recognize that a quarter goes into a whole number 4 times, and then there are 2 quarters left over, so that would be the same as 1.5. And if you are doing that now, then you can be really happy with your progress in fractions if you have the ability or you've practiced them and done the work enough to feel confident that, hey, 6 quarters is 1.5 because there are 4 quarters in a whole, and that leaves you with 2 quarters left over. And as I said, that's 1.5. Question 9, 50% of 1,880 is just 1,880 divided by 2, because 50% is a half. Okay, and to work out 1,880 halved, I would go 1,800 halved is 900, and then 80 halved is 40. So it gives you 940. You could have said, what's 10%? 10% is equal to 188. I just divide by 10. Then to get 50%, I obviously just multiply 188 by 5. And again, that's going to give you 940. If you wanted to work in fractions, okay, if you needed to work in fractions, 50% is 50 over 100. Times 1,880 over 1. We know that 50 over 100 is a half. Okay, so I would always encourage you to simplify your fractions before doing the calculation, because now instead of saying 50 times 1,880, I'm saying 1 times 1,880. And instead of dividing by 100, I'm dividing by 2. Okay, which for me is a lot easier. And again, that's going to give you 940 when you work that out. Okay, I will show you the short division method for doing 1,880 divided by 2 just to prove the answer. Okay, so 2 goes into 18 9 times, because remember it doesn't go into 1. All right, 2 goes into 8 4 times, and 2 doesn't go into 0. Okay, and then if I wanted to check that, like I've been saying all along, 940 times 2, okay, 0, 8, and 18, and you can see all of that works out quite nicely. Okay, guys, I hope you guys have remembered those concepts that we've spoken about and practiced repeatedly. I'm sure by now you're almost ready to go on your own way and encounter any of these calculations in any classwork, homework, or assessment, and you should feel really confident and comfortable in being able to get them correct. But please, guys, please check your work and use the checking strategies that we've spoken about. Let's get into the main theme for today. Okay, so today we're going to start looking at multiplying terms together. So we're still dealing with algebra. So in algebra, we usually leave out the multiplication sign, so we don't need to use it. Any numbers must be written at the front, and all letters should be written in alphabetical order. So for example, if I said 4 multiplied by A, I only need to write 4A. I don't need the multiplication sign there. Okay, so I need to know that 4A means 4 multiplied by A. 1 times B can be written as just B. Sorry, I almost said 1B, but we actually don't need to put the 1 in front of the B, because if there's B by itself, there can only be one of them. Okay, so in algebra, we don't write the 1, we just leave it as B. So B times 5, remember at the top I said the number should come first, so it'll be 5B, not B5. Okay, so these are just the right ways of doing things, and you need to learn the right way of doing things early on so you can create good habits. 3 times D times C. Again, at the top of the screen, you can see we mentioned alphabetical order. Okay, so that should be 3CD. Again, no multiplication signs, and C comes before D. And then 6 times E times E. Some of you might be thinking, right, that's 6EE. Okay, but remember that a number multiplied by itself we write as a squared number. So 2 times 2 can be written as 2 squared. And it's the same for algebra. E times E is written as E squared. And then you need the 6 at the front to make 6E squared. Okay, so those are just some do's and don'ts. Make sure you understand them and make sure you create positive habits from the beginning. So when we simplify using index notation, x plus x plus x plus x plus x, how many are there? There are 5 of them. So we just write that as 5x. All right, so that's when we add. But now when we multiply the same number of x's together, it's exactly the same as if we had 2 times 2 times 2 times 2 times 2. We would say, all right, if we wrote that using index notation, so remember index notation is using powers and indices, so we would have said 2 to the power 5, and it's exactly the same with algebra. So there we would say x to the power 5, and that is called index notation. Okay, so similarly, x times x is x squared. X times x times x, x cubed. There are 3 of them. And if there are 4 of them, then yes, you're correct. It would be x to the power of 4. So please notice the difference between adding and multiplying. Okay, they're very, very different. And go back over the screen to make sure you understand the difference between adding and multiplying in algebra. So we can use index notation to simplify expressions. Okay, so what do I mean by that? If I have 3p times 2p, well, we know 3 times 2 is 6, and we know p times p would be p squared, and that would give you 6p squared. Okay, so what I've done there is I've expanded 3p times 2p just to show you that that is 3 times p times 2 times p, and then we multiply the numbers together to get 6, and we multiply p times p, and that gives us p squared. For the next example, you've got q squared times q cubed, bit of a tongue twister. And if I wrote that out in full, it would be q times q, that's what q squared is. And if I wrote q cubed out in full, it would be q times q times q. Now you can see there are 5 of them, and that's written as q to the power of 5. So I'm hoping you guys have recognized something in that second example, but if not, I'll explain it to you at the end. The same thing happens in the first and the third example. So 3r means 3 times r, so 3 times r, and then r squared is r times r, so there's an expanded notation. So quite correct, that would be 3r squared. 3 times r is 3 times r, so 3 times r, and then r squared is r times r, so there's an expanded notation. So quite correct, that would be 3r squared. 3 times r is 3 times r, so 3 times r, and then r squared is r times r, so there's an expanded notation. So quite correct, that would be 3r And then your last example, 2t means t times t, and then the other 2t means t times t, okay? Or you can say 2t squared, purely because there are two of them, okay? Either way, that expression simplified is going to be 4t squared. Now you'll notice that in each example, and the best examples for me to use is q squared times q cubed. The final answer is q to the power 5. If you look at q squared, so you look at the 2 and you look at q cubed, the 3, if I add 2 plus 3, it gives me the 5 at q5. The same with 3r times r squared. If there's 1r and then there's 2 r's, and 1 plus 2 is 3. So what we say is when you multiply, you add the exponents. Okay, and the exponents, for example, q squared times q cubed are 2 plus 3. Okay, so that's also a handy rule for you to understand moving forward. What happens if I've got brackets? Okay, so remember we've always said order of operations, brackets comes first. But you guys know by now that I cannot add a plus b because they are not exactly the same. They are not like terms, okay? So what does this 4 and then in brackets a plus b mean, okay? It purely means that it's 4 multiplied by whatever is in the bracket. So remember, we don't write the multiplication sign, okay? If we did write the multiplication sign, we would write 4 multiplied and then in brackets a plus b. Okay, but we can leave that multiplication sign out because we know now what it means. So basically it's a plus b plus another a plus b plus another a plus b and plus another a plus b. So we're adding a plus b 4 times. Now that's quite a long way of doing things, and you know, for a plus b plus a plus b plus a plus b plus a plus b, we can't simplify that any further. But what we can do is we can multiply whatever is in the bracket by whatever is outside the bracket. So now if I remove those brackets, I'd have a plus b plus a plus b, a plus b plus a plus b for all of them. And now you can clearly see that there will be 4 a's plus 4 b's. Okay? So you can also just have a look at the original expression at the top of the screen and say 4 multiplied by a is 4a, and then plus, because there's a plus sign in the bracket, 4 multiplied by b is 4b. Okay, you don't have to write it out the long way at the bottom of your screen. That's just showing you how we get to 4a plus 4b. Okay. Sometimes we need to multiply out brackets and then simplify. So what do we mean by that? If I have the example on your screen, such as 3x plus 2 multiplied in brackets by 5 minus x, brackets always comes first. So I know I cannot do 5 minus x, but I can remove the brackets by multiplying 5 minus x by 2. So we need to, as it says on the screen, multiply the bracket by 2. So we still have the 3x, we still have plus, but now we say 2 multiplied by 5 as indicated by the red curved line, and that's going to be 10. And then we need to have 2 multiplied by minus x. Okay, so that's really important. The signage here, so the positive and the negative sign is really important, and that's going to give you minus 2x. Okay, now we can simplify 3x minus 2x is just x, and we're left with the add 10. So that would be simplifying that expression by multiplying out brackets. Okay. Again, go back, listen again, make sure you understand before moving on. So expanding brackets and then simplifying. Here's another example, and this example I've put in because I've got 2 negative signs. On the previous example, if you go back, there was a positive and a negative sign. Okay. So here, same rules apply. Remember that we do not write 1. So in actual fact, that is 4 minus 1 times 5n minus 3 in brackets, but we don't write the 1, okay? But we still need to multiply the brackets by negative 1. So it would be negative 1 times 5n is going to be equal to negative 5n. Then we have negative 1 times negative 3. and a negative times a negative is a positive, and that gives us positive 3. So now I will continue to have minus 5n, okay, and it's going to be plus 7 because 4 plus 3 is 7. So it's really important to understand here that you keep the sign that's in front of like 5n. It's got a negative sign in front of it, and you can see we keep that negative sign in the answer. But you need to know that when you're working with negative and positive signs, that a negative times a negative is a positive, and a negative times a positive is a negative sign. So here's a longer, and I'm just trying to challenge you guys, and I'm trying to scaffold your learning here. So we've started off simply at the beginning of the lesson, and now we're going to some higher order questions. But the same principles apply. Don't get nervous or anxious because the equations or the expressions, sorry, this is an expression, not an equation, there's no equal sign. Don't get concerned because they are longer. The exact same rules and principles apply. I first multiply out the brackets. So in the first bracket, I've got 2 multiplied by 3n minus 4 in brackets. I must do that first. I must also do 3 multiplied by 3n plus 5 in brackets. So 2 times 3n, 2 times 3 is 6. I keep this the n. 2 times minus 4, that's positive 2 times negative 4 gives me negative 8. Plus 3 times 3n is going to be 9n. And now I've got 2 plus signs or 2 positive signs, so it's positive 3 times positive 5 stays positive 15. Now I can go and simplify. So I can say 6n plus 9n is 15n. And I can say minus 8 plus 15, that's going to give me plus 7. So your final answer is 15n plus 7. Okay? Again, when I simplified my expression, I looked at the signs in front of whatever term I was working with, and I included that in my calculation. Here's another one for you to try and do, or for us to talk through. So the first thing we need to do is multiply out the brackets, because brackets comes first. Then we collect like terms. So 5 times 3a is 15a. 5 times 2b is 10b, and all positive, because there are only positive signs there. But on the second bracket, we have a negative 2. So it's negative 2 times 2a is a negative times a positive. So that becomes a negative 4a. And then negative 2 times positive 5b is a negative times a positive, and that becomes negative 10b. Now I can collect the like terms. So the like terms are 15a minus 4a, because they've both got the same small letter a. So that's going to be 11a. And I can do 10b minus 10b, and that's going to give me 0. So my final answer is 11a. Hope it's making a little bit more sense to you guys. If not, rewind and see if you can understand it, maybe watching it a few times. At the end of the day, it's practicing these things that's going to make you understand it, not just only watching a video recording. So there's an online activity with a memo accompanying this lesson, which has got loads of examples for you to do and the answers. So you can do the example, mark it off yourself, see where you went wrong. If you still have a problem, send me an email at the email address at the bottom of your screen. Guys, that brings us to the end of this lesson, and you know by now that we like to finish on the game of 24 because it's really good for your mental arithmetic. It practices your order of operations. So on each card you got 4 numbers. You need to use those 4 numbers and a combination of the operational signs, and you need to come up with the answer of 24. Okay, so you need to have 3 equations that equal 24. If you can come up with more than 3, so maybe you can get 2 or 3 on each card, then you can be really happy with your mental arithmetic capabilities, and that should give you a lot of confidence moving forward. Grade 7s, thanks very much for joining me today. Algebra can be a daunting topic, but if you just go through the process step by step, remember the principles, And yeah, sometimes when you draw things out in full, or if you write it in expanded notation, it makes your life a lot easier. And I'd encourage you again to re-watch this lesson and make use of the online activity and memo to make sure that you understand the work moving forward. All the best for a great day ahead. Cheers.